Beyond Earth, humanity's ultimate evolution on alien worlds. Have you ever wondered how humanity could evolve in response to the harsh environments of alien planets? Imagine us not just in spacesuits and helmets, but fully transformed, evolving beyond recognition. From bodies with metallic skin to humans with glowing tails, the future might be far stranger than we think. In today's episode of Galactic Discoveries Quest, we take you on a mind-bending journey through the cosmos, exploring how humans might adapt to the most extreme and bizarre conditions found on distant worlds. How would we survive the extreme heat of Mercury? How would our bodies change to endure the frozen storms of Neptune? Could we evolve to live near a black hole? This is not just a tale of space exploration, it's a story about the future of humanity itself. A story that begins right now, with our imagination. But one day, it may be real. Stay tuned, because what we're about to explore could reshape everything you thought you knew about evolution, survival, and the future of life in the cosmos. Chapter 1, Mercury, the furnace and the freezer. The harsh realities of Mercury. Mercury, the closest planet to the Sun, is a world of extremes, a place that challenges even the most advanced of human imaginations. During the day, its surface temperature soars to a blistering 430 degrees Celsius (806 degrees Fahrenheit), hot enough to melt lead. At night, temperatures plummet to an unforgiving -180 degrees Celsius (292 degrees Fahrenheit), colder than the Arctic. The lack of an atmosphere means there is no protection from the intense solar radiation, nor any blanket of warmth during the bitter cold nights. For any life as we know it, Mercury would be a death trap. But for future humans, Mercury might just become a crucible for evolution. How humans might adapt to Mercury. Imagine a future where humanity has colonized Mercury, and instead of being confined to underground bunkers, we have fully adapted to live on the planet's surface. But how would we survive in such extreme conditions? 1. Metallic, reflective skin. Picture colonists moving across Mercury's surface with shimmering, metallic skin that reflects the harsh sunlight. This would be a protective layer, similar to the reflective qualities of metallic foil, shielding us from lethal solar radiation. Such skin would not only protect us from the intense heat, but would also provide insulation during the freezing nights. It would be an evolution designed for extreme efficiency, turning us into human-shaped solar panels. 2. Compact, heat-resistant bodies. Surviving Mercury's temperature extremes would require a radical shift in our body structure. Imagine humans becoming shorter and stockier, with a body built to conserve energy and withstand temperature fluctuations. Densely packed tissues would help us minimize heat absorption during the day and retain warmth at night. This new, compact form would make our ancestors look more like futuristic knights, armored and efficient. 3. Enhanced vision. The sun's intensity on Mercury would force our eyes to adapt. Advanced, multi-layered corneas would act like natural sunglasses, while our retinas would develop filters to shield our vision from the sun's searing light. Over time, we would develop adaptations allowing us to see clearly in an environment that would blind an unprotected human. 4. Temperature-regulating cells. Mercury's dual nature, a furnace by day and an icebox by night, would require an extraordinary cellular adaptation. We might evolve to produce heat-shock proteins and antifreeze-like molecules that enable our cells to withstand both extreme heat and bone-chilling cold. These proteins would allow us to endure the unforgiving temperatures without freezing or burning. Life on Mercury, a glimpse into the future. In the near future, humans on Mercury would look strikingly different. Picture a colony with reflective buildings and bioluminescent lights. The colonists, shimmering under the sun's glare, move gracefully with their new adaptations. At night, their homes glow softly, providing the warmth and light necessary to survive in the darkness. They are no longer human as we know it, they are transformed, living testaments to humanity's resilience. Would you visit Mercury? Would you dare to embrace such extreme transformation? Let us know your thoughts in the comments below. Chapter 2, Venus. The crushing oven. Venus's unforgiving nature. Venus is often called Earth's twin, but this couldn't be farther from the truth. It's a world of pure hostility, with surface temperatures of 465 degrees Celsius (869 degrees Fahrenheit), making it hotter than Mercury despite being farther from the Sun. The atmosphere, composed mainly of carbon dioxide, creates a crushing pressure about 92 times that of Earth's. It's a place where humans, as we know them, would be instantly crushed, boiled alive, or suffocated in seconds. But could humans adapt to Venus? What if we evolved into something entirely new? Evolving to survive Venus. In order to survive Venus, we would need to undergo extreme modifications. 1. Mirror-like skin, similar to Mercury. Venus would demand reflective skin. However, here, our skin would not only have to reflect sunlight, but also resist acid rain. Colonists might evolve a corrosion-proof epidermis with natural, built-in properties to neutralize the sulfuric acid that rains down from the clouds. 2. Stocky, muscular frames. To withstand Venus's crushing atmospheric pressure, humans might develop short, muscular frames. Think of a body designed for resilience, with reinforced bones and dense, compact muscles that allow us to survive in such extreme conditions. These bodies would look almost like armored giants, strong, thick, and ready to endure the relentless environment of Venus. 3. Sulfuric acid filtration. In Venus's toxic atmosphere, our lungs would evolve to process the carbon dioxide and sulfuric acid present in the air. We might develop specialized filtering systems in our respiratory systems to extract trace amounts of oxygen while neutralizing harmful sulfuric compounds. 4. Internal cooling systems. In a world where temperatures soar above 460 degrees Celsius, internal cooling systems would be essential. Similar to desert animals, we might evolve mechanisms that cool the body from within, allowing us to survive the planet's sweltering temperatures. Life on Venus, thriving in hell. Now imagine a thriving Venusian colony, where buildings glisten under the oppressive heat, and armored humans navigate the sulfuric air. Their movements are slow and deliberate, conserving energy, but their strength and determination are undeniable. Communication would be possible through advanced helmets designed to filter the acidic atmosphere and amplify sound. Venus may seem like hell itself, but humanity would find a way to not only survive, but to thrive in the most hostile environment in the solar system. Chapter 3, Mars. The first frontier. Mars, humanity's best hope of all the planets in our solar system, Mars is the most likely candidate for human colonization. With its cold, thin atmosphere and dusty surface, it presents serious challenges. But unlike Venus or Mercury, Mars offers potential for life, for transformation and adaptation, not destruction. Martian evolution. A new kind of human on Mars. Humanity would undergo distinct evolutionary changes that would allow us to survive the planet's unique challenges. 1. Orange skin. Mars's UV radiation is intense, and over time, Martian colonists would evolve to develop keratin-rich pigmentation, turning their skin a vibrant shade of orange. This would act as a natural sunscreen, protecting the colonists from harmful radiation. 2. Tall, slender frames. Mars's gravity is only 38% of Earth's, which would result in taller, slender bodies. Colonists might have longer limbs and reduced muscle mass, giving them an almost alien elegance. These bodies would be adapted for Mars's low gravity, maximizing energy efficiency and reducing the wear and tear on bones. 3. Dust-resistant lungs. Mars's thin atmosphere and frequent dust storms would require specialized lungs. These lungs would be capable of filtering out the fine dust particles that frequently blanket the planet, while tear ducts would produce protective fluids to shield the eyes from the constant dust exposure. 4. Radiation-hardened cells. The intense radiation on Mars would necessitate an evolutionary shift at the cellular level. Over generations, Martian humans would develop DNA repair mechanisms that help us withstand radiation and reduce the risk of cancer. These cells would have the ability to quickly fix damaged DNA, ensuring the survival of future generations. A Martian day in 100 years. Imagine a Martian city, a shimmering dome under the reddish sky, with orange-skinned colonists roaming the surface. They would no longer be the humans we know, but a new, evolved species suited perfectly to the harsh Martian environment. Would you call Mars your new home? Would you embrace these evolutionary changes for the chance to live on another world? Chapter 4, Jupiter, a world without ground. The gas giant challenged. Jupiter, the largest planet in our solar system, is a massive gas giant with no solid surface. With its powerful storms, including the Great Red Spot, a hurricane larger than Earth, Jupiter is a world unlike any other. Colonizing this world may seem impossible, but humanity's creativity and resilience know no bounds. Becoming Jovian, floating in the sky to survive in Jupiter's upper atmosphere, humans would need to evolve into something entirely new. 1. Gliding forms. Without ground to walk on, humans might evolve wing-like appendages to glide through Jupiter's thick, turbulent atmosphere. These wings would allow colonists to move gracefully through the dense clouds, taking advantage of the planet's fierce winds. 2. Chemical sensors. In Jupiter's atmosphere, which is made mostly of hydrogen and helium, humans would need to develop chemical sensors to navigate the environment. These sensors would replace traditional sight and smell, helping humans detect chemical changes and stay safe in an atmosphere filled with deadly gases. 3. Pressure-tolerant cells. With intense atmospheric pressure and extreme temperatures, humans would need cells that could withstand these crushing conditions. Special pressure-resistant cellular structures would allow us to survive in Jupiter's deep, dense atmosphere. Life among the clouds. Imagine floating in the sky of Jupiter, gliding through the clouds in an atmosphere of swirling gases and storms. Colonists might move freely in a world without ground, their bodies adapted to the pressure and chemical environment. Instead of walking on land, they would soar through the clouds in gliding cities that float above the chaos below. Conclusion: the infinite potential of humanity as we venture out into the stars and beyond. The question is not just about where we go, but who we will become. Each planet, each environment will shape our species, creating a future humanity as diverse as the universe itself. Which transformation excites you the most? Could we really evolve to survive on these alien worlds, or is it all just science fiction? Let us know your thoughts in the comments below. And don't forget to subscribe to Galactic Discoveries Quest for more cosmic adventures.